Determine the shear and moment throughout the beam as a function of x. To solve this problem, first of all, we need to realize that this problem will be made up of two sections. One will be from 0 to 4. The other one will be 4 to 6. And before we proceed with anything, we first of all need to find our external reaction forces. And we know our horizontal at B will be 0. We're going to take a moment about the point B. We're going to have 600 Newton, 2 meters away from B. And then clockwise AY, 6 meters away from B, all equals to 0. Solving for AY, we get our solution as 200 Newton. Now we can sum the forces in y direction in order to find our solution for BY. So we can have negative 600 Newton, positive 200 Newton from A, and negative positive BY all equals to 0. Solving for BY, we get our solution as 400 Newton. Looking at the diagram, we know for our first half, which is from 0 to 4 meters, our shear is going to be 200 Newton. And then from 4 to 6, it's going to be negative 400 Newton. Similarly, we know that if we take the integral of shear, we get our moment. So we're going to do that. So our moment for the first half is going to be simply 200x plus c when we take the integral. And now to find our c, or the constant, we know our moment is 0 when x is 0. Therefore, our c is 0. So ultimately, for region 1, our moment is going to be simply 200x Newton meter. Now for our moment number 2, our moment for region 2, we're going to have negative 400x plus c as our initial equation. And now to find our value for c, we know that moment 2 will be 0 when x is 6. Solving for c, we get our solution as positive 2400 as value for c. Therefore, our equation for the moment as a function of x is going to be negative 400x plus 2400. And that's our solution. Determine the shear and moment throughout the beam as a function of x. To begin, we need to convert our distributed load into point load. So it's going to be 15 times 4, which is 60 kilonewton. And then A is a pin connection. So we're going to have two reaction forces, AX and AY. AX is going to be 0. B is a roller, therefore just BY is going to be our solution. Now we can take a moment about the point B to find a solution for AY. So we're going to have 60 kilonewton times 4 meters, because it's 4 meters away and it's counterclockwise. And then we have clockwise AY, and it's 6 meters away from B, all equals to 0. Solving for AY, we get our solution as 40 kilonewton. Now we can sum the forces in y direction to find our solution for BY. So we can have BY negative 60 kilonewton and positive 40 kilonewton, all equals to 0. Solving for BY, we get our solution as 20 kilonewton. Now that we have all the required values, we know that this beam needs to be divided into two regions. One will be 0 to 4, the other one will be 4 to 6. To find the shear for region 1, we know that it's going to be part uniform distributed load and part our external reaction force. So we know that our W, which is our uniform distributed load, is equal to 15 kilonewton per meter, and it's a negative. And we know our shear is integral of our distributed load. Therefore, when we take integral of the W, we get our shear as negative 15x plus c, which is a constant. And to solve for the value of the constant, we know when x is 0, our shear is 40 kilonewton positive, and this gives us our solution for c. Therefore, our equation for region 1 becomes negative 15x plus 40. Now for the second region, we know our distributed load is 0. So therefore, whatever value we have at 4 is our shear. So in this case, we know that we'll have to use the equation from shear, value of the region 1 for the shear to solve this equation. So we know we have negative 15x, and we know that region 2 starts at 4 meters plus 40 from the original shear. So solving this equation, we get our solution as negative 20 for our shear for region 2. And now as for the moment, we know if we take integral of each of the shear, we can get our moment. So let's solve for moment 1. So for moment 1, we know it's going to be negative 15x squared divided by 2 plus 40x plus c, which is our constant. Now to find the value of our constant, we know when x is 0, moment is 0. And that being said, we know our c is going to be 0. Therefore, our equation for moment 1 is going to be simply negative 15x squared divided by 2 plus 40x. For moment 2, if you take its integral of our, if we take an integral of the shear for region 2, we're going to have a moment 2 as negative 20x plus our constant. And we know our moment is 0 when x is 6. Therefore, solving for constant, we get our value as 120. And our moment equation becomes negative 20x plus 120. Determine the shear and moment throughout the beam as a function of x. We know at A, we have a pin connection. We can have two reactions, horizontal and vertical. Horizontal will be 0. B is a roller, so there's going to be one vertical reaction. Now to find external reaction forces, we're going to take a moment about the point B in order to find a solution for AY. So we have counterclockwise 12 kilonewton meter moment, and then we have clockwise AY, and it's 6 meters away, all equals to 0. Solving for AY, we get our solution as 2 kilonewton. Similarly, we can sum the forces in y direction in order to find a solution for By. So we have positive By, positive 2 kilonewton, all equals to 0. Solving for By, we get our solution as negative 2 kilonewton. Now that we have all the values, we can start finding our functions. So for our shear, and before we even go to shear, we need to recognize that we will have two regions here. One will be 0 to 4 meters, and the other will be 4 to 6 meters. Now our shear for region 1 is simply going to be integral of our initial value, you can say, which is 2 kilonewton, and this is for region 1. So our shear for region 2 will be 2 as well, because there isn't any other change. Now we can take the integral of each of these shears to find our moment for each region. So for moment 1, we're going to have our equation or function as 2x plus c, which is a constant. And we know when moment is 0, x is 0, therefore our c is 0, and our function for region 1 is going to be 2x. For region 2, we have again 2x plus c, but in this case, we know our moment is going to be 0, definite 0, when x is 6. And solving this, we know our constant is going to be negative 12, and therefore our equation for region 2 is going to be 2x take away